OK， 2016年5月1号下午5点某分，5点20几分。Take two， 那个1之3，开始。
Good morning, honorable judges. This is our IMMC presentation. And this is the outline of our presentation. For question 1, we use statistics to find the average cost of the bonus, that is A. Question 2, we consider several factors to determine the range of R. And R is. Question 3, discuss the possibility to go bankrupt, P-break, to decide an event to self-insurance in multiple events, and make P-break and average odds relationship into a chart. And question 4, in different price P and possibility to break the record P in each event, discuss the condition to choose best strategies. Next, question 5, we make two models. 1 is same P, and 2 is different. This is our topic record insurance. As you see on our presentation, our topic is about the insurance fee of the marathon. For question 1, we have to know the average cost of the bonus. First, assume the quality of our risk is as high as IAAF, International Association of Athletics Federation. So we will hold 19 races per year, and we can search related information on the website. And this is the statistics, and this is IAAF. This is the statistics we get from the internet. Then, based on the statistics we get, we can calculate the rate of record breaking. Then we can get the average cost of it. AM is male's average cost of the bonus, and AF is females. Next, we can add them together and we can get the answer. For question 2, for insurance company to operate successfully, we have to sustain an expected profit, and it must be lower than the realistic profit, or it will be bankrupt. Second, the more commission we get, the higher the fee will be. And according to the law of supply and demand, we can know the higher the fee is, lower the people will join the race. So we have to make a balance between them. Next, the quantities of race competitors and attendance fee, they must be lower than the maximum of the fee that people can accept. Last, combine the two formulas together and we can get the answer R.
Okay, in question 3, as the position of the committee, we must find out whether we should take a risk. In order to cover the risk, we need a numerical we defined as A, which is the minimum quantity of races that exhaust our funds. Ideally, to keep the operation, we can sustain the high probability. So there has an upper limit of our risk of being bankrupt that we define as P max, which will correspond with the inequality below. Plus, we can unfold the simulation into binomials we see below. Eventually, we make these results into charts to see the different relationship about parameters. As we see, the probability of being bankrupt presents a positive correlation with the accumulation of our overage, but we can see there are several specific points which represent as the red points we see on the charts that emerges discontinuously. That is where the numerical A has changed. Okay, and we also changed some different parameters to see the effect. And these two charts, we changed the initiative funds. We can see when the initiative funds become larger, the risk of being bankrupt will decrease sharply. And another one, we changed the multiple R to see the risk. And now we have the idea that when the multiple become larger, the times of the appearance of these spots will become more. And that is the conclusion of our comparison about these parameters. In question 4, to sustain the operation, we will discuss the two conditions of it. But no matter what condition it is, we will have to decide our purchasing access first. These access will present us of the sequence we define as S. We see the example. In the sequence, the element 0 means that we don't do self-insurance at the event, and 1 means we did. These results will become our potential decision to purchase the insurance. So, to make sure that they are considered without any risk, S will be correspond with the inequality below. That means that the potential bonus we will have to pay cannot be larger than the sum of our fund. At the moment, we can see the sum of our overage will become the equality below. After the consideration, we will adapt the results that our saving the most. Now, take the risk into consideration. We must to find out the rate will be safe. And the important step is that we'll have to find out the sequence B we need. The sequence B represents the situation with the breaking the breaker in the events. We see, for example, the 1 means that the event has already break the record, and 0 means not. So to ensure that we'll be safe to operation, the sequence B should accord with the inequality below. That is, the bonus we must to pay won't larger than sum of our initiative funds and our overage.
Okay, this is going to question 5. Question 5 asks us to provide a useful and efficiency solution to deal with this model. We decided to use the developer tool Visual Studio, depending on its clear unity and very common environment, which based on Windows operating system. We developed a program. This program is used to simply calculate those parameters. Our target is to find the best result that corresponds with the real situation as appropriate as possible. The program it can find the specific points as starting points, which help us look for the best result, simultaneously showing the strategy for our demands. And this is our figure show. You can see this is our code, and this is our program. And we have a short clip, and you can see. Okay, it tells me we cannot play the video, so I think it just costs us 30 seconds because it is used is iPad, so we cannot play it. And we change the F0, R price, event P max to how to say， 反正就是这样，反正就是30秒。啊，我们用 iPad 现在不能播，希望大会那边的电脑也是，如果是电脑就可以了。好，好，30秒差不多过去了。Thank you for listening.
大概。
大概就。